Welcome, amazing friends, and let's solve this challenge on Math Olympiad. I tell you, it's just very simple, but we have to be very careful. It's tricky, okay? Now, I already know you have your solution in your mind, but be careful because that solution is just one out of the many solutions you are going to get. Just observe that x is raised to power of 6. So it means we are expected to have 6 values of x. Yes, 6 values. Now, how do we do that? I'm going to show you. And don't forget to tell us how helpful this is to you. In the comment section, it helps us to serve you best. Let's do this together. So we begin this with solution. Now, what do you do? Let's bring down this. So we're going to have x to the power of 6. This is positive, okay? We can choose to remove it. You do it by subtracting. So you subtract from both sides, subtract 64 is equal to, if you subtract here, it gives you 0. Now, what do you do next? Just remember that 64 is the same as 2 here is 32, 2 is 16, 2 here is 8, 2 is 4, 2 is 2, and 2 is 1. So you see we have up to 6 2's giving you 64. So we can rewrite it to be x to the power of 6 minus 2 raised to power of 6, okay, is equal to 0. Did you see that? Now, what do you do again? Just remember this rule of your exponent that says when you have a to the power of m to the power of n, it means a to the power of the powers multiply. So it's going to give you mn. Did you see that? So it means that we can apply this here. And to do it, we are going to rewrite this to give us what? We can write it to be x to the power of 3, raise it to the power of 2. You've not changed anything. If you multiply this to, it gives you back 6, obeying this. Okay? Do same here. We're going to have 2 to the power of 3, then raise it to the power of 2. If you multiply this, it gives you, and everything is equal to 0. Now, what do? You observe carefully that this is leading you to difference of 2 squares. Just watch. Okay? Now, let me remind you of the formula for difference of 2 squares. It says a squared minus b squared is equal to a plus b and a minus b. Now, applying this, we are going to now have, so this gives us, so we can say that this is our a and this becomes our b. So let's apply it carefully. So to do it, we are going to have s cubed plus 2 cubed, okay? Then into x cubed minus 2 cubed. Everything is equal to 0. Amazing. Now, when you have two of these to be equal to 0, it means that either of them is equal to 0, okay? So it's either that this is equal to 0 or s cubed minus 2 cubed is equal to 0. Now, what do we do next? Now, we solve it from here to have. Let's take this first. So it's going to give us s cubed plus 2 cubed is equal to 0. Now, remember your sum of 2 cubes formula, which says a cubed plus b cubed is equal to a plus b into a squared minus ab plus b squared, okay? So this formula is going to be of help to us because you observe carefully that this is of this form. So in that case, we are going to now have, this gives us x plus 2, okay? I hope you are with me there, into our a, remember, is x. So we have x squared minus multiply x and 2. It gives you 2x. So we're going to have 2x. Then our b is 2. So we have 2 squared is 2 times 2 to give us 4. So we have plus 4 here. Did you see that? It means that this is equal to 0. Okay, let's take it down. We are going to now have x plus 2 is equal to 0. Okay, we have gotten another one now. And x cubed, x squared minus 2x plus 4 is equal to 0. So what do? To get x at this, you need to subtract 2 from both sides. And if you do it, x gives you negative 2. So we have gotten one value of x. Okay, now let's solve this. This is quadratic. So let's solve it quadratically to get the value of x here. So to do it, we are going to now use the formula method. And remember, the formula method says x is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. Okay, just remember that your a is the coefficient of your x squared. So here our coefficient of x squared here is 1, because when you have a variable without a number before it, it has an invisible 1. Okay, so a is 1, and our b is always the coefficient of x, which is -2. Then our c is the constant term, which is 4. So we are going to plug this into this formula, and if you do it, we are going to have, so let's take this off. We are going to have x is equal to negative into, our b is negative, did you see that? Then plus or minus square root of, your b is also -2, you square it, minus 4, our a is 1 and our c is 4. Okay, then divide it by 2, multiply, our a is 1. So if you simplify this, you have x is equal to, negative multiplies negative is +2, plus or minus square root of, -2 squared is -2 times -2 to give us +4. If you multiply this, it gives you -16. Okay, then divided by 2 times 1 is giving us 2. So if you simplify this, you are going to have x is equal to 2 plus or minus, subtract this, it gives us -12, then divided by 2. Okay, you observe that there is a negative sign inside this square root, and whenever there is a negative sign inside the square root, it's no longer a real number. Okay, it has become an imaginary and leading to a complex solution. So in this case, what you do here is that we are going to remove this, and to remove it, we are going to rewrite this to be x is equal to 2 plus or minus square root of -1 multiply 12 gives you back this. I hope you know that. And then divided by 2. Okay, now remember this rule of your radicals, which says that, let's just adjust it and write it here. We have, if you have root a is equal to, when you have it this way, is equal to square root of a multiply square root of b. Okay, so in this, we are going to have it as x is equal to 2 plus or minus square root of -1 is multiplying square root of 12. Okay, then divided by 2. Now what do you do again? We keep simplifying. To do it, you are going to have x is equal to, so let's take this off. So we have x is equal to 2 plus or minus. Now remember that each time you have square root of -1, we usually use an imaginary unit to represent it, and we have it that I is equal to square root of -1. Okay, so in this case, we are going to replace this with I, so we are going to have I. Now this 12 has a perfect square in it. Now to bring out the perfect square, we have it that the highest perfect square here is 4. So it means that 4, and when you multiply 4 by 3, it gives you back 12. So you can write this to be 4 times 3. I hope you are seeing what I'm doing. And then divide it by these 2. Okay, now let's simplify again. So this gives us x is equal to 2 plus or minus I. Now this 4, because it's perfect, its square root is 2. So we are going to bring that 2 out from this root. Okay, so you write it out. Then this 3 is not perfect, it remains in the root. So we are going to have root 3. Did you see how we got that? Then divided by 2. At this point, we can choose to use these 2 to divide each of the numerators, because the 2 here is the denominator. Okay, so it means we have x is equal to 2 divided by 2 plus or minus 2i divided 2i root 3 divided by 2. So this can take off this. I hope you are seeing it. And when a number divides itself, it is 1. Please take note. So it means we have x is equal to 1 plus or minus root 3i. Did you see it? So we have gotten this solution, and to split it, we are going to now have it as x is equal to 1 plus root 3i. Okay, this is another solution of x. And we also have x is equal to, take the negative now. So we have 1 minus root 3i. this is another solution for x. So you observe we have gotten three solutions now. This is the second and this is the third. Now recall also that, remember that we also have it that x cubed minus 2 cubed is equal to 0. Okay, so we are going to still solve this the same way we solved the previous. So to do it, we are going to remember that this is now leading us to difference of two cubes. So we remember the formula for it, which is a cubed minus b cubed is equal to a minus b, okay, in bracket, into a squared plus ab plus b squared. Now let's apply this here. It's going to give us, this is our a, so we have x cubed minus 2 cubed is equal to, we have x minus 2, okay, into x squared plus multiply x and 2, it gives you 2x, then square this, it gives us 4. Did you see that? So this has given us this, and remember everything is equal to 0. So simplifying again, we have from here we are going to also have, we have x minus 2 is equal to 0 because these two are equal to 0, okay? Or that x squared plus 2x plus 4 is also equal to 0. Interesting. So what do you do here? Just add 2 to both sides because this is negative. If you do it, this goes off. So x is giving us 2, okay? We have gotten the fourth solution. Now let's solve this one. This is also quadratic. Use the same quadratic formula, which we say x is negative b plus or minus square root of b squared minus 4ac divided by 2a. And you know here our a is 1, our b is 2, and our c is 4. So plug this into the formula. It's going to give us now x is equal to negative of these two, okay, plus or minus square root of, our b is 2, so we have 2 squared minus 4, our a is 1, and our c is 4. Then divide it by 2 times our a is 1. I hope you are with me there. Now let's simplify it. We are going to have x is equal to negative 2 plus or minus. Then square this, it gives us 4, minus multiply this, it gives us 16. Then divide it by 2. Multiply this, it gives you 2. This gives us x is equal to negative 2, okay, plus or minus. If you subtract this, it gives us negative 12. Then divide it by this 2, okay. Now what do you do again? You still remember we have negative, okay. We just apply the same principle. So we have negative 2 plus or minus. This gave us negative 1 multiplied by 12 over 2, okay. And we have it that x is equal to negative 2 plus or minus. This negative 1 is your I, and this one gave us, for this 12 we got 2 root 3, okay, and is divided by 2. So this 2 takes off itself 1, divides this, you have 1, and divides this 1. Did you see it? So we're going to have it as x is equal to negative 1 plus or minus, then we have root 3i. So if you split it now, we're going to, and you know we are dividing by 1, and when you divide anything by 1, it returns you to that number. So we are now making conclusion that our x is equal to, so for this, our x here is negative 1, okay, plus root 3i. Okay, this is another solution of x. This is the fifth one. And also have it that x is equal to negative 1 minus root 3i. Okay, so this is the sixth solution of x. So in conclusion, we have it that the values of x are x is equal to 2, okay, then the second value of x is negative 2, the third value of x is equal to 1 plus root 3i, then the fourth value of x is 1 minus root 3i, okay, then the fifth value of x is, we have it as negative 1 plus root 3i. Did you see that? And finally, the sixth value is -1 minus root 3i. So these are the 6 values of x. Now remember that these two are what we call the real solution, okay? You can find these ones on the number line, and these ones are found on the complex plane, okay? So these ones are complex solution. I hope this is clear. So you've seen that we've been able to have 6 solutions for this polynomial, and I hope you learned a lot. Don't forget to tell us how helpful this tutorial is to you. Don't forget to also share with your friends to learn the skills we displayed, and give this tutorial a thumbs up, subscribe for more tips. I'll see you in our next class. Stay cool till then. Bye.